Oh, hello and welcome to this lesson in our study of linear algebra. In this topic, we talk about curve fitting of straight lines for any given set of points. Okay, so in curve fitting, we are given n number of points. So we have first point, that's x1, y1, x2, y2, x, y, yn, x, n, y, n. That's when you have n points, and we want to determine a function f of x such that f of xj is approximately yj, where j is starting from 1 to n. Then this type of function can be a polynomial function, exponential function, or it can be a transcendental function. Okay, if we require straight equality, we set f of x 1 to y. Then we solve this problem by using the Newton interpolation or the Lagrange interpolation. But in method of least squares, the straight line should be fitted through point x1, so through n points. Okay, that's x1, y1, x2, y2 up to x and yn, so that the sum of the square distances of those points from the straight line is what? Minimum. Okay, and the distance is measured in the y direction or the vertical direction. So first of all, you equate the function to y. The function can be a polynomial function, any other function at all. Okay, so let's assume the function is a straight line, so we equate we let f of x be a plus bx. Okay, then you equate f of x to y. Okay, then after that you find q, so that q is what? Sum of square error. Okay, and it's given by this, that's the sum of the square differences between y and a plus bx. Then after that you find the partial derivatives of q with respect to each of the unknowns. Okay, the unknowns are a and b, so we find the partial derivative with respect of q with respect to a, and we equate to 0. Then after that we find the partial derivative of k with respect to b, then we also equate to 0. So when you have q to be q is given by sum y minus a minus bx all squared. Okay, so the partial derivative of q with respect to a, you differentiate this with respect to a using the chain rule. Okay, so first of all you differentiate the whole function, so you get 2 multiplied by y minus a minus bx. Then you also differentiate what is in the bracket with respect to a. So when you are differentiating with respect to a, you hold other variables constant, so you hold y, b and s constant. Okay, so when you differentiate y with respect to a, you get 0. When you differentiate minus a with respect to a, you get minus 1. Okay, then you equate to 0. So that will be negative 2 times this. That's what we have here. And we go through the whole process again. That's, you find the partial derivative of q with respect to b. When you solve this, you get that. Okay, so now you can now simplify these two equations. When you simplify, you get the following equations, where the sum of x either is the sum of the x coordinates, and yi2, that's the sum of the y coordinates. Okay, then you solve the problem. It will help you to find the values of the unknowns, which is a and b. Okay, so let's solve the following examples. So first of all, Here's a question. Using the method of least squares, we have to fit a straight line to the points. So we have 4 different points. Okay, so that's why we have our n to be 4. That's 4 different points. And we find the sum of x coordinates. So have -3 plus -0.1. So the first one is -1.3 plus -0.1 plus 0.2 plus 1.3. When you simplify, you get 0.1. Then sum of the square of the x coordinates. So -1.3 squared plus -0.1 squared plus 0.2 squared plus 1.3 squared, you get 3.43. Okay, then you find the sum of the y coordinates. So that will be 0.3 plus 1.099 plus 0.808 plus 1.897. When you do that, you get 3.907. Then the sum of the product of x and y coordinate. So you multiply -1.3 by 0.103, then you add it to -0.1 by 1.099 plus 0.2 times 0.808 plus 1.3 times 1.897. So here you just find a product of the elements in each of the points. Okay, so each point have 2 dimensions, that's x and y coordinate. You find the product in each of them, then you sum them up. Okay, so that one to give you this, that's 2.339. so therefore our equation becomes this. We have 2 equations. Can now solve the following equations, the system of equation, using the normal elimination and substitution method, or you can use the Cramer's rule. Okay, so when you solve, you get A to be 0.9601, B 0.6670. Okay, so therefore straight line is given by y equals 0. Y is in this form, y equals a plus bx, and we know our a, we know our b. So the straight line is given by this, which is 0.9601 plus 0.6670x. Okay, there is a question, another interesting question for us. You can pause this video and try your hands on this question. So we have to fit a straight line. You have to fit a straight line to the points. So we have 4 different points by the method of least squares. Okay, so you have the first point to be 0, 3, second point to be 2, 1, third point to be 3 minus 1, and last point to be 5 minus 2. Okay, so now let's solve this problem. So here are the points. We have 0, 3, we have 0, 3, have 2, 1, 3, -1, 5, -2. Okay, so we have 4 points. Okay, so now let's find the sum of the x coordinates. So we have 0 plus 2 plus 3 plus 5, and that's 10. Sum of the y coordinates gives us, which is it gives us 1. That's 3 plus 1 minus 1 minus 2, that's 1. Then sum of the x squared. Okay, the square of x coordinates. So 0 squared plus 2 squared plus 3 squared plus 5 squared, we get 38. Then sum of xy. So 0 times 3, that's 0. That's 0. 2 times 1, that is 2. 3 times -1, which is -3. 5 times -2, that's -10. When we simplify this, we get -11. We are required to fit a straight line, and we know that a straight line is given by this, that's y equals to a plus bx. Okay, so the sum of square roots from definition is given by, that's we let q be sigma isomorphism from 1 up to 4. We are using 4 because we were given 4 points. Okay, so that's yi minus a minus bxi all squared. That's this equation. So we find the partial derivatives of q with respect to each of the unknowns. Okay, so the partial derivative of q with respect to a is given by this, then we equate to 0. Okay, so when we do that, we divide through by negative 2. Okay, we divide through by negative 2. So when we divide through by negative 2, we get only this. Okay, that's sum. Then you multiply by the yi minus a minus bxi, then equal to 0. When you want to expand brackets, this one changes to sigma y minus a is constant, okay, minus b sigma xi. Okay, but when you are finding the sum of a constant, let's say sum of a constant a as I starting from 1 up to n, the same as a plus a up to the last value, and this is the same as a times n. Okay, so we can write the second term. We can write this term. We can write this term. We can write this term, okay, as 4a. Okay, then we make summation of y the subject of this equation. So we send these two terms to the other side of the equal sign. When we do that, we obtain this equation. Again, we find the partial derivative. We find the partial derivative of q with respect to b. Okay, so when we do that, we get this. We can divide through by negative 2. Can divide through by negative 2, and when we do that, we left with this one. Then we expand bracket. So x y, that's you get the first term will be sigma xy minus a sigma xi minus b sigma xi squared. That's x times y xy x times a ax. So sigma ax by is constant, so you can decide to bring it out of the summation sign. Then x times bxi gives you bx squared, okay, or bxi squared, but b is constant, so you can bring it out of the summation sign. Okay, so we make this term the first term the subject. When we do that, we get this. Okay, so now we know a value of sigma xi, we know a value of sigma xi squared, and we know a value for this. So first of all, let's consider this one. Okay, so we have 4a, then sigma xi, that's the sum of the x coordinates. Sigma xi is 10. Okay, this is sigma xi is 10, and sigma yi is also what, 1. So that's why we had this equation. That's equation 1. So this is sigma xi and this is sigma yi. Okay, then the next one, that is a sigma xi. We know a sigma xi to be 10, to get 10a, and sigma xi squared, sigma xi squared is 38. Sigma xi squared is 38. Okay, so you can substitute it. We can substitute it into this. Okay, so when we do that, we obtain 38b, and sigma xy is negative 11. Okay, so we solve these two equations simultaneously. We can use the normal elimination and substitution method, or we can use the Cramer's rule. Okay, you can use any of them. So let's use the Cramer's rule to solve this problem. So when you want to use, you are using decrements, you have to express the system of equation in the form ax equals to b, okay, where a is the coefficient matrix. That's 10. We have this matrix, okay, 4, 10, 10, 38. Then x is the unknowns, that's ab, and this b is the values on the right hand side of the equal sign, or in other words, b is the constant terms. Okay, so in solving a Cramer's rule, you consider the coefficient matrix and you find the determinant, okay, such that when you are solving for a, you replace the coefficient of a. See, the coefficient of a are 4 and 10. That's from equation 1 and 2. Okay, you see, we have these two equations. We have these two equations. So the coefficient of a is 410, coefficient of b 1038. Okay, so that's what I'm talking about. So you just replace the coefficient of a by the constant terms b, which is 1 negative 11. Okay, so then you find the determinant. So that's what we have here. That's why we have what, 1 negative 11. Then you maintain the element in the second column, that's 1038. You find the determinant. Then you divide by the determinant of the coefficient matrix A. Okay, so the determinant, when you simplify this, you get 37 over 30. That's A. Then B. For B, you have to replace the coefficient of B by the constant terms. Okay, so we replace 10 and 38 by 1 negative 11. Then we find the determinant. Then we divide by the coefficient. We divide by the coefficient, the determinant of the coefficient matrix. So when you do that, we have negative 27 on 26. Okay, negative 27 on 26. Then the straight line is given by y equals to a plus bx, where a is 37 over 13, so that's what we have here, and b is negative 27 on 26. So this is our straight line. 37 over 13 minus 27 on 26x, where 37 over 13 is our y-intercept, and negative 27 on 26 is our slope. Thank you.